Can you see?
Yes, sir.
Can you see now?
Yes, sir.
Okay. So we'll start. Okay. So we have sorry, we have discussed principle of superposition. Principle of superposition. Any doubt on principle of superposition? All of you have understood it. Principle of
Yes.
superposition. Hmm. Okay. Now today we'll start with the next thing, that is this one. That is, yesterday I just ended the lecture with this, that what is mechanics and what is structural analysis. Okay. So see, in the third semester when I took your class of engineering mechanics, I have no, I don't think I have not taken your class of engineering mechanics. In section 1 I have taken. So you see, mechanics is basically, what is mechanics? Mechanics is basically, it's a branch, it's the branch of physics, and it studies the behavior of physical bodies. Basically the physical bodies, how a physical body will behave under the forces or displacements. That is what it studies. Okay, that is what is actually mechanics. So when a physical body is subjected to any force or any displacement, okay, so force and displacement both can be the cause, and because of those causes, what is the effect, what are the subsequent effects of those causes on the bodies, that is being studied using the mechanics. Okay. And if you think about engineering mechanics, where in engineering mechanics we study about the rigid bodies, so we don't consider the deformation of the body in case of engineering mechanics, right? And in such case, engineering mechanics is being divided into two cases, that is, one is statics and other one is dynamics. So in case of statics, what we do, we study basically the bodies at the rest or the bodies with uniform velocity. This is very important. See, static is something where you don't think that body is moving, that doesn't mean that it is always dynamics. Okay, when there will be accelerating body, then it will be dynamics. But if a body moves with uniform velocity, then it will be considered as a static kind of problem. Okay. And what is dynamics? Dynamics is nothing but the accelerating body. That means under the forces, when the bodies are accelerating, in such case the study of mechanics will be called as dynamics. Now after the third semester course of your engineering mechanics, you have studied about solid mechanics course, right? So in the solid mechanics, in case of solid mechanics, what have you studied? So basically you see, solid mechanics and strength of materials are the same thing. Solid mechanics and strength of materials are same thing. And what have you studied under the solid mechanics is basically, if you remember, the deformation of bodies under the forces. So you see, engineering mechanics and solid mechanics differ in this way. In case of engineering mechanics, you are studying only the rigid body mechanics. So rigid bodies are being studied in case of engineering mechanics. Whereas in case of strength of materials or solid mechanics, you now understand that the deformation of the bodies under the forces are studied. So you see, in case of engineering mechanics, you didn't heard about the term stress, whereas when you started the solid mechanics, then you have started learning about the term stress. And what is stress? Stress is the internal response of a body under the force. So force per unit area, the body is giving some resistance. Whenever a body is tried with a force to be getting deformed by the force, then body gives some resistance, and that deformation resistance is basically given by some internal property of the body, and that is nothing but the elasticity of the body. And that way stress will come up, and that stress will be actually getting developed when a body is being tried with a force and it is being deformed. So that is the point you must be very very clear about. That is the basic point of difference between engineering mechanics and solid mechanics. You should be very clear about this thing. See, in many interview questions this type of questions are asked. What is engineering mechanics? What is solid mechanics? What is the difference between engineering mechanics and solid mechanics? What is statics? What is dynamics? In many cases people always tell that that body with any velocity is under the condition of dynamics, but no, that is not true. A uniform velocity body will be considered as a static problem. It's not a dynamic problem. Okay, now you see, going forward, then we have studied about strength of materials, we have studied about solid mechanics. Okay, so we have studied about the nature of a deformable body. So how much stress will be getting generated, how much bending stress will be getting generated inside the body, how much torsional stresses will be getting generated inside the body, how much hoop stresses or hoop tensile stresses will be getting inside the body, how much shear stresses will be getting inside the body. So all these things we have studied in case of strength of materials. Now you see, this strength of materials and structural mechanics, this is looks to be almost similar, but you see, in structural mechanics what we will be studying, will be focusing on the behavior of structure. We will be studying on the behavior of the structure under the loads. So we will be studying structure as a whole. We will be studying the structure as a whole, and we will be studying the structural behavior under the loads. And thus you can define structural analysis is as a process by which the structural engineer determines the response of a structure to be specified loads or actions. Response of a structure to the specified loads or actions. Okay, so to be, I have written to be, it should be to the. So structural analysis is a process by which the structural engineer determines the response of a structure to the specified loads or actions. Now what is this response, we will be understanding little bit more in the next slide. But you see, you need to understand this thing very clearly, that response means how does the force is getting developed inside the body. So basically any structure will be undergoing the two kinds of development, undergoing the deformation or the response in two kinds. One is the collapse and the other one is the serviceability. So you see, in the previous lecture we have discussed that any load, whenever it will be acting on the structure, there will be deformation, and if the deformation is excessive, then there will be collapse. So for studying any structure, basically while you will be studying the responses, under the action of loads for a specified load, then you must study whether the structure will be getting collapsed or not. And this collapse thing you will be understanding in more detail while you will be studying your reinforced concrete structure, which you have in this semester. That is, while you will be studying about reinforced concrete structure and the limit state of collapse. One term we will learn about, that is limit state of collapse. So basically collapse is nothing but, is this the student Mizan Haidar? What? Hello? हेलो
सर, किसी को एडमिट अब मत कीजिए, क्योंकि जिसका भी है सबका लॉगिन के लिए अथी नहीं मांगेगा, किसी को भी।
हाँ, किसी को तो लॉगिन नहीं मांगेगा, सो आई विल नॉट एडमिट एनीवन। ओके, नो प्रॉब्लम। So where is the screen? Where has the screen gone? Okay, now you see. So two things you will have to understand. One is the limit state of collapse. So see, when you will be studying reinforced concrete, you will be understanding about it in more detail. And the second thing is limit state of serviceability. That means when a structure will be subjected to any kind of load, it should not go beyond some deformation. If it goes beyond the deformation limit, then its serviceability limit exceeds. Are you getting this point? So collapse and serviceability are two different things, you understand? So serviceability, see, a structure may be getting under some deformation, but still it will be under service condition. However, if it goes beyond that deformation condition or if it gets collapsed, then it will not be under service condition. So both the things you need to be analyzing and understanding while doing the structural analysis. Now in the next slide you will be understanding about what are the responses. So as we have said that structural analysis is a process by which the structural engineer determines the response of the structure, response of a structure. Now which responses we will have to study in structural analysis? See, it's very simple. You have studied it in solid mechanics also, but in this case you will be studying it in, you see, these three things you will be understanding. Okay, so the purpose of structural analysis, is to determine at any point of a given structure. So what are the responses you will be studying, and who will be creating those responses? Responses will be created or caused by the applied loads. It will be caused by the applied loads and forces, right? And what are the things you will have to study? You will have to study the reactions, you will have to study the internal forces, and you will have to study the deformations. See, this is what actually you have also done in case of solid mechanics, if you remember. So you see, when you have studied about a simple supported beam under a point load, so what is the thing actually? The load, applied load in that case is your point load. And what you have studied for that point load? When a point load is acting on a simple supported beam, what are the things you have studied? Can anyone tell? What are the things you have studied? Can anyone tell?
Sir, repeat the question, sir.
See, when a simple supported beam in solid mechanics, let's say, in solid mechanics you have studied simple supported beam, a simple supported beam under a point load. Then for a simple supported beam under a point load, what are the things you have studied? What are the different responses you have studied?
Sir, bending moment, shear force, deformation.
Yes. So first thing you have missed it, that is reactions. You have,
yes, reaction, sir. Sorry.
Yes, first thing you have studied is reaction, right? For an external load coming onto a structure, see, a structure cannot be standing without a support, right? That's what we have yesterday understood, right? A structure needs a support, and when there is a support, so whenever there will be some external load coming onto the structure, at the support there will be reactions. So in structural analysis, first thing you will have to study is the reactions at the support. For due to what? Due to the applied loads and the forces. And the next thing you have mentioned, that bending moment and shear force. What are those? What are bending moment and shear force? Bending moment and shear force are nothing but the internal forces, right? Internal forces. Because of the load acting on the beam is getting bent downward, and while the beam is getting bent downward, the forces are getting generated inside the structure, and that is actually your bending moment and shear force, isn't it? And because of the bending moment and shear force, if you remember, due to the bending moment and due to the shear force, you will be getting some bending stress and shear stress, right? So you could find out, once you know what is the bending moment at the structure and what is the shear force at the structure, you should be able to find out what is the bending stress and what is the shear stress. because you remember the equation m by I equal to sigma by y. From that you should be able to calculate the what is the bending stress. You can calculate VQ by IB. From that you will be able to understand what is the shear stress, right. So once you know the reactions, you should be able to calculate internal forces, and once you know the internal forces, you should be able to calculate different stresses which is getting generated inside the structure. And the third thing, if you remember in case of a simple supported beam only, also we have studied using Macaulay's method or double integration method, the deformation of the structure, right. So what is the displacement?
dy by dx.
Yes. So
Yeah.
what is the displacement of the structure at different point, right. So that is actually nothing but your deformation. So you see, solid mechanics and structural analysis are coming just hand in hand, right. So what you are studying actually, what you will be studying in structural analysis is basically the responses of a structure due to the applied loads and forces. And what are the responses you need to study? You need to study reactions, you need to study internal forces, and you need to study deformations. Is it clear? Okay. Now you see this thing I have also discussed previously with you, that important structural properties. See, while discussing about strength of materials or solid mechanics, the very beginning initial classes I have discussed about the structural properties, very important two structural properties, and the most important two structural properties are strength and stiffness. You should not get confused about these two properties. See, strength is different and stiffness is different. What is strength? Strength is basically the ability of the structure. It is the ability of the structure to withstand a given stress without failure. Are you getting? So once a structure is being stressed, and how a structure can be stressed? A structure can be only stressed using the external load acting on it, or it can be only stressed using the deformations being put on the structure. So once a structure is getting stressed, the structure, because of its internal property, will have some kind of resistance to it, and the structure will be having some ability to withstand the stress without the failure. And these characteristics of a structure will be considered as strength of the structure, and it depends on, and it obviously it will depend on type of the material and type of the force. See, it's not only tension or compression. We should write tension, compression, bending, shear, whatever kind of forces will come onto the structure. So it will depend on that. Okay, tension or compression or bending, we should write or bending or shear. So any force can come. Okay, so any kind of force, when it is acting on the structure, because of its material property, it will try to withstand the stresses generated by those forces, and the ability of the structure to withstand that stresses so that it does not fail is actually the strength of the structure. And see, thus it will depend on the material property as well as the type of the force, because one structure may be very good in tension, but it may not be good in compression. One structure may be very good in compression, but it will not be good in tension. One structure may be withstanding very high amount of shear, but it will not be able to sustain the amount of tension. So that is why the strength of the structure will depend on not only on the material. You should understand this. It will not only depend on the material, however, it will also depend on the type of load or type of force. Now the next very important property of the structure is stiffness. Now what is stiffness? So stiffness, if you see, stiffness is basically the property that is related to the deformation, and that is what we are studying actually in strength of materials. You see, related to deformation. So when under the action of the load a structure is getting deformed, then you will be considering the property of stiffness. And you see, the stiffer the structural elements, deformation will be less under the same applied load. So if a material is much stiffer than some other material, on the same load, if you apply a same amount of load on a structure which is stiffer, that will deform less due to the applied load. And you must understand this stiffness will depend on the type of material, that is modulus of elasticity or whatever modulus you have, modulus of CR, modulus of this, modulus of that. So it will depend on the type of material and structural shape and configuration. This is very important. Structural shape and configuration is very important. See a structure which is having a triangular shape, shape will be much stiffer than a structure which is having a oval kind of shape, because the stiffness will be inherently coming to a structure because of its shape, and thus the shape of the structure is also an important property while you are calculating the amount of stiffness. And also you should understand the structural configuration. So what is structural configuration? Structural configuration means, you see, in the previous lecture I have told you that a structure will be consisting of many elements, right? Total complete structure will be consisting of many elements. Let's say the previous day, whatever one building we have seen, that will consist of different elements like beam, column, foundation, then slab, roof slab, these, that, other things, right? So all these things will come together as structural configuration. How you place your beam, how you place your column, how you attach your beam to the column, how you are placing your beam together, how you are placing your columns separately, in which orientation you are placing your column, all these things will come under structural configuration. And once you understand the structural configuration, that will also add to your structural stiffness. So stiffness, you should understand, it's a property related to deformation, whereas you see strength is a property, structural property, which is related to the stress in the structure because of the external loading. So see, now you should understand what actually you will have to study in structural analysis. You will have to study the structural analysis, the response of a structure, and response means the reactions, the internal forces and the deformations under external loading, considering the strength and stiffness of the structure, because you cannot go away with the strength and stiffness of the structure. Okay, so considering the strength and stiffness of the structure, you will have to study a structure. Now next, so let us go to the next slide. Now you see various types of structural forms you can see. In the yesterday's lecture I have mentioned that loads, whenever you will be coming to a structure, and we have said loads can be of different types, dead loads and live loads. Now dead loads can be of different types, live loads can be of different types. Now whatever may be the loads may be of different kinds, like tension, compression, flexure, torsion, shear. Different types of loads can come onto a structure, right? So if you see the different types of structural forms, you should understand this very clearly. You have already understood it in your solid mechanics, but again you refresh this. See the types of structural form, the basic types of structural form which you will be studying in structural analysis. Particularly they are tension and compression structure, flexural beams and frame structure, and surface structure. Okay, so you see tension and compression structure. What is a tension structure? You see, this is a tension structure. A rope is hanging from a fixed portion, or pinned one, and one load is being hung over here, 1 kilonewton load, and because of this you see this rope is under a force which is basically nothing but your tension, right? So this is actually your tensile force. Now you see, if you are thinking about compression, then you see multiple number of bricks or blocks you have kept, right, and you put a 1 kilonewton load over here, and you are putting it on top of the ground. So what will happen? Because of this load, you see there will be a compressive force getting generated inside the structure. So see, this is also a structure, this is also a structure. Don't think these two are not structures, because these are being stable assembly. These are standing on the floor, or this is hanging from something. So this is structural form, these are stable structural assembly, and because of the loads, you see one structure is undergoing tension, on the other hand the other structure is undergoing compression. Okay, now you see what will happen because of this tension and compression. You see, because of this tension, what may happen, if you increase the amount of tensile forces, what will happen? Gradually, if you try increase, then at one moment it will come, there will be failure, tensile failure, and that is what you need to understand. This is actually your collapse. In the previous slide, or in the beginning of the discussion, we were discussing about collapse, right? So this is actually your collapse. So if you go on increasing these tensile forces here and here, if you go on increasing the tensile forces, at an instance will come when the structure will not be able to withstand any more tensile force. Exactly the same way it will happen to the compressive failure also. At one moment the structure will come when the structure will bend like this, and it will not be able to take up any more compressive stresses, and thus the structure will fail and that will collapse. But you see, the structure will survive until and unless it reaches the collapse point. So if you increase the tensile force, if it elongates up to certain limit, after you remove the tensile force, because of its elasticity, the structure will come back to its original position, and that is what is Hooke's law, right? So when it will come back to its original position, you see the structure is surviving. However, when the loads are increasing to such a limit that the material cannot withstand the amount of stresses getting generated by the loads inside the structure, in such case the structure will collapse. Okay. Now going with this tension and compression structure, after that you see this is this structure, if you see this one. So what is this? This is basically a flexural structure. You see, a beam is standing, a beam is just kept onto support, and you put a load. So this is a kind of a simple supported beam, and then you see there is bending coming onto the structure. So you see this bending is nothing but your flexural thing. So flexural movement is coming, flexural deformations are coming onto this structure, and you will notice, you will observe, we will go forward when you will discuss about frames, you will understand how the flexures are coming also to the frame structures. Okay, and the load carrying capacity of those structures, you see, in this case the load carrying capacity of this structure will be obtained using the bending capacity of this structure. So the amount of bending stress it can take, depending upon that, it will be able to take up the load. And you see, if you keep on increasing this load, at an instance will come when this structure will also collapse. So you cannot go beyond that load, and you will have to restrict the deformation to such a limit that it should not go for failure due to serviceability conditions. Okay, so two things you should understand here, that whenever you will be doing any structural analysis, you must be considering and finding out the reactions and internal forces or stresses as well as you will have to study the deformation, because you need to limit the deformation to certain limit, because if you do not limit the deformation to certain limit, beyond that deformation limit the structure may go and then it may collapse. So to avoid it, you will have to check for the deformation while you will be analyzing a structure. Okay. Now you see, let us try to see, okay, another one type of structure is surface structure. What is surface structure? What is surface structure? See, surface structures are nothing but your slabs. See, the floor slab, the ground floor slab, the middle floor slab, the roof slab, these are basically actually surface structures. So see, these surface structures are kind of structures which also carries load using its membrane action. Membrane action means it will be just behaving like plates, and just like the plates it will be carrying the load, and ultimately from those membranes the loads will be getting transferred to the beams, and then from the beams the loads will be transferred to the columns, and from the columns the loads will be transferred to the foundation, and then from the foundation it will be going to the ground. Is it clear? So membrane structures are basically, or the surface structures are basically nothing but the slabs, or different kinds of slabs, or different kinds of roofs, kind of roof slab kind of, or floor slab kind of structure. Now next is, let us try to understand this. These are very simple example of tension structure, compression structure, compressive failure, then you see the flexural structure. Now let us try to see different types of structure which you physically see in your surroundings, and as a civil engineer you must now understand which kind of structure will be undergoing which kind of forces. Okay. So you see, first we will start with, because this is tension is one of the important thing. So let's say, what is a tension structure? See, this one is a tension structure. See, have you noticed this kind of structure, cable structure? This Kolkata Vidyasagar Setu, have you noticed? So many of you have seen it. Okay. So see, these are the cable stayed bridge or suspension bridge. Can you see this? So these are the cables, simple cables, and you see this bridge slab, this suspension bridge, this the deck slab, you see there is no piers, there is no columns underneath. So who is carrying this total structural load? See, on this deck slab, this deck of the bridge has got huge amount of dead load, and on top of this dead load, lot of cars are moving, lot of vehicles are moving, people are moving, many kinds of loads are going through. Then you see the wind load is also acting on this. So who actually is carrying this much amount of load? It looks to be hanging like this. So basically it is being stretched by the cables. You see, these cables are getting stretched, and basically these cables are actually taking the load whatever is coming onto the structure, and by which means that actually is being taken by tensile forces. And you understand from this that whenever you will be discussing about cable structure, it is there in your syllabus also, when we will be discussing about cable structure, you see there will be always tension will be always coming onto the cables. There will not be any compression, there will not be any bending, there will not be any shear, there will not be any torsion onto the cables. So a tensile, whenever you will be studying a cable structure, your primary focus will be to find out what is the amount of tension getting generated on those cables. You need not to worry about how much bending will come, how much shear will come, how much this will come, how much that will come, because a cable structure will be always under tension. there cannot be any compression, there cannot be any bending, there cannot be any shear in those structures. Okay, so you see, simple thing, very simple thing. And this usage of cable structures you will be finding out in suspension bridges, sometimes you will be seeing it in some roof structures. Then you have noticed the transmission lines. The transmission lines means the electrical transmission. Okay, so in the electrical transmission structure you see big towers are there. So who is actually holding those cables, heavy loaded cables? So that those being taken by those transmission lines being basically supported by tensile mechanism of the wires. Okay, so you must now understand that for a cable structure it has same tension all along. So you should understand it that a tensile structure like cables, whenever you will be analyzing, you should not worry about another one thing also, that how much tension will be here and how much tension will be there. For a continuous cable, the tension will be remaining same at its every position. These are very minute and important points I am telling you, must remember. These are the basics of structural analysis. So when you will be learning about the mathematics of cable structure, you should remember these fundamentals, that a cable structure will have same tension all along. That means if you cut the cable structure at any point and if you find out the tension at any point, you will notice the tension will remain same. And next is, it cannot withstand any kind of compression. It cannot withstand any kind of compression. Okay, now let's say next type of structure. So cable structure, I hope that you have got some understanding about the cable structure. Now let's go to the next type of structure, that is actually your arch structure. Have you noticed, have you seen this kind of structure?
Yes, sir.
Yes, very good. So see, these kind of structures, this many British time railway bridges, if you notice, many bridges are like this. Okay, and in the ancient buildings also you will notice these kind of structural forms are very common. And nowadays also, if you see, for giving some architectural beauty in some buildings, recently constructed buildings and recently constructed different kinds of beautiful things, this kind of structural form you will notice. And what is this kind of structural form? In civil engineering we will be calling it as arch. What will be calling it? Arch. Okay, so this is actually your arch structure. And you see, the arch structure, you very carefully understand this. See, this arch structure is basically under compression, just unlike the cable structure. See what I have said, because cable structure have same tension all along. Just opposite to it, you see a arch structure, if a load acts on this arch structure, you see a load acts on this arch structure, what will happen? This structure will try to get along this way, and then you see there will be a compressive forces or compressive stresses will be getting generated across the structure. So basically you see a arch structure, arches basically will carry the dominant permanent load case, usually full dead load in pure axial compression. This is very important. See, unlike a cable structure which is under pure axial tension, a arch structure will be under pure axial compression. You must understand this very carefully. Have you understood it? See, this one, when a arch structure, you see, this one is your arch structure, this one is your arch structure. So this is being cut over here, and this arch structure, you see, is being supported over these two pillars, and these are the two pillars. These are the two pillars. One is this one and one is this one. And you see the load, whatever is coming from the top, this load is being put over here, and because of this load, you see a compression this portion of the structure will be under pure compression, and this portion of the structure will be under also pure compression. So you see, in earth structure will be usually under the dead load condition will be under pure axial compression. Is it clear? Next you see, let's go to another one structure. See, you have noticed this structure. What is this? You have studied it in your solid mechanics also.
It's a
This
truss,
is
sir.
truss, yes,
Sir.
truss structure. Okay, truss structure. So you see, this truss structure, basically you will notice this kind of truss structure in railway bridges, or you will be seeing it in some factories, or you will be seeing it while you will be observing some kind of steel structure where the roofs are being supported under the truss. So exactly this example, if you see, these are the trusses, right? These are the trusses, and see, the roofs are being supported using these trusses. So it's not that truss will be always coming in a bridge structure. It may be in some kind of normal structural form also, where the roofs are being supported by trusses, or any other thing may be getting supported by trusses. But you must understand another one thing very, very carefully for a truss structure also, that a truss structure, whatever load may be coming on a truss structure, the truss will be always loaded at its joint. See, the whatever load will be coming on a truss structure, the loads will be always acting at its joints. See, here, the load cannot act over here. Load cannot act over at the middle of this. The load will be acting at always at the joints. So whenever you will be idealizing a truss structure, you will have to convert your loads so that it will be acting at the joints of the trusses. You should be very, very carefully understanding it. See, in no case in a truss structure the load can act at the middle of this structure, at the middle of this member, at the middle of this member, at the middle of this member. It cannot act. Okay, if it acts in such a way, then it will not remain a truss structure. It will become a frame structure, or it will become a beam, or it will become a column. So in case of a truss structure, you must understand that the external load, whatever will be acting on it, will be acting at the point of the joints. So only at the joints the external loads will be acting. And now you must understand the under the load, what will happen to a truss member? See, all the members of the truss structure will either be in tension, or it will be under compression. Okay, so you see, so in two ways you can explain this. See, either you can say the members are in compression, or the joints under in tension, or you can say the members under in tension and joints under compression. Both way it is true. So whatever way you explain, your member and joints will be always under tension and compression. It cannot be anything else. So in case of a truss member, you will never get a case where the shear force will be arising inside the member, where the bending moment will be arising inside the member. It will be always tension and compression. It will be always compression and tension. It cannot be anything else. So the three basic structures now you have understood. You see, first we have understood cable. So you see, for a cable structure it will be always tension, right? For a compressive structure, you see, arch, we will be getting mostly the compression. In case of truss structure, whatever you will be getting, that will be actually either tension or compression or both in a member. And you should understand, in a truss structure the external loads will be always acting at the joints. You must remember these points. Next, now let us come to another one structure. What is this? This is actually a frame structure. Okay, see, this is what is idealized. See, this is a bridge deck. See, how does it, how do you understand now what is the difference between this and this? See, this is also a bridge deck. Now you see, this bridge deck is being pulled by this tension cable. These bridge decks are pulled by these tension cables, and these tension cables are held by a pier, by a structure, something like this. Okay, whereas you see this structure, the difference between that. See, in this structure you see these bridge decks are being held by these two columns, and there is a beam underneath it. Have you understood? So see, in this case, if you idealize it, then you see this deck slab, whatever deck slab it is there for the bridge, you can consider it as a membrane, or this one, whatever we have discussed. So a deck slab can be considered as a surface structure or load carrying, which is carrying its load by membrane action. Now this load, these membranes will be ultimately transferring this load to this beam, and this beam will be ultimately transferring load this to column, and then it will be going to the foundation. So if you idealize this structure, if you just make it a simplified view, so what you are getting? So you see, this is actually the beam. So this beam, whatever is being supported, whatever it is given over here, which is actually supporting this slab, whatever is supporting this slab will be getting supported, this slab will be getting supported by this beam, and you see this beam is being supported by these two columns. So you see these two columns will be supporting this beam, and you see what load will be coming to this beam. The beam will be taking, hello, anything?
No sir, no sir.
Okay. So the load will be coming, to the beam. You see, the load will be coming to the beam from this slab, and through the membrane action, a portion of the load from this slab structure will be transmitted to this beam, and a portion of the load from this side of the structure will be this side of the bridge slab or the deck slab will be transmitted to this beam, and you see these loads are being shown over here like this. Is it okay? So you see, thus this kind of structure will be becoming a combination of structure which is actually is having beam and column, and this kind of structure in civil engineering, or the idealization of this kind of things in civil engineering, will be calling it as frame. Okay, so these structures will be calling it as frame, and you see the difference between the cable structure, earth structure and truss structure, cables, arch and truss and frame. These four basic kind of structures, when you understand the difference, you see cable will be always under tension, arches will be generally under compression, your trusses will be always under either tension or either compression, whereas the frame structure, when you will come to it, is the most critical and complex kind of structure. It will be subjected to different kinds of things. That is, it will be primarily under bending, and it will also have shear, it will also have compression, it may also have tension. So you see, all the four things will come onto a frame structure. All the four things may come to a frame structure. That is tension, compression, bending, shear. You see, when the load is acting on this, see the beam is bending, so the bending action will come to this beam. So whenever there is a bending action, you see there will be shears coming on this beam, so there will be shear action. On that, you see this beam will be transferring the load to these columns. So you see the column will be under direct compression, as well as because of this rigidity of the joint, because of this rigidity of this joint at this point and at this point, what will happen? Because of the pressure, not only the direct compressive forces will come, but also there will be some kind of small bending will come onto this column structure. So the column will be under axial forces as well as bending. Okay, and also you see, if this beam is not rigid, in such case, you see, because of this deformation of the beam, some axial amount of tension will also get generated inside the beam. However, you must understand one thing, that in case of civil engineering structural analysis, in most of the cases we consider the beams to be the rigid structure. Okay, and because of its rigidity, generally the axial tensions are neglected in case of beams. So I hope you have now got understanding about the different structural forms of civil engineering, right? Now you see, the last slide today's I will show you. See, that is what I have told you, that membrane structure. Okay, so see, this what are these? These are columns, right? Now you see, there are beams, and on top of the beam you see there are slabs, floor slabs. This is a multi-story structure. Can you notice? So you see, this is a typical kind of structure which you have come across in any multi-storied building. And you see, these slabs, these portion of the slabs, these are actually basically your membranes, or these are called flat plates. Okay, and how does these flat plates will carry load? It will carry the load using the membrane action, which we will not be studying in our structural analysis course much. What we will be just considering, that from the membrane action, some portion of the load will be just getting transmitted to the beam, and ideally, finally we will be idealizing the beam, and we will be saying that beam is under the load, and then we will be analyzing the beam. And then if the beam is being supported by some column, we will be analyzing the column. Okay, now these flat plates, again you see, in some kind of structures you will notice this kind of structures which are basically folded plates. So in case of folded plates also, using the membrane action only, the load will be transferred from the membrane to the supporting structure like beams and columns. But in this structural analysis course, we will not be much discussing about this membrane analysis and other things. We will be mostly concentrating on these four things. We will be analyzing the cables, we will be analyzing the arches, we will be analyzing the trusses, and we will be analyzing the frames. And for analyzing these things, we will be using different methods, different methodologies, different types of analysis, and using different types of methods we will be learning how to analyze the structure in a better way, and how to analyze a structure in easier way. Okay, so I think we stop here today. In the next class, again on Sunday, we will be discussing about different support connections and other things. Then we will be actually moving into the your little bit of syllabus part. Okay, so another one class I will take for discussing the basics and introduction of structural analysis. Okay, so I think we conclude here today. If you have any question, please you can ask. Any question?
Sir?
Sir, frame structure consists compression or tension, sir?
Pardon?
Sir, frame structure, sir?
Frame structure. Okay, frame structure. You see, this is actually your frame structure. Right? So you
Yes,
see
sir.
what I said. In a frame structure, you see a frame structure will be consisting of beams. This is actually your beam. Can you see the movement of the cursor? This is actually your beam, right? And
Yes, sir.
this is actually your column. See, if you idealize this structure from this bridge deck to here, you see, this is actually your beam, and this beam is getting supported by two columns, and the load is coming from this slab to the beam. So this is actually uniformly distributed load, let's say. So you see, because of this load, what will happen? This beam will be getting deformed in the downward direction. So obviously bending will come into the structure. Then you see, because of this, because of the load coming from the beam, so beam will have some reaction. Beam will have some reaction because beam is being supported by the columns. So see, when there is a reaction, there will be some opposite thing on the other direction. Newton's third law says it, right? So when the beam is supported by the column, when the beam is being supported with the reaction, in the opposite direction there will be a force coming, in this direction there will be a force coming, right? So actually what will be happening, actually I will just show you with this. So whenever there will be a reaction coming like this on the beam, right, this arrow you can see, then what will happen?
Sir.
Then what will happen? There will be some amount of this thing will come on the other direction, because then only equilibrium is possible. So what will happen?
Yes, sir.
Whenever this downward thing will come, you see this column is supported on the ground, so there will be compressive force getting generated. So there will be compression coming under the column. So there will be bending in the beam, there will be compression in the column, and you see, because of this compression, direct compression will come in the column. Along with that, whenever there is a rigid joint, you see at this point, if the rigidity is there, then because of this rigidity, the beam will not be able to extend in this direction, or it will not be able to extend in this direction, correct? Because of the rigidity, it cannot extend. So what it will do, it will try to keep it safe in such a way that it remains stable. So what will happen? There will be a deformable shape, something coming like this. So you see, your column will be also coming under some kind of bending, okay? So there will be bendings getting generated inside the column. So you see what is happening. So your beam will be under bending. Obviously when there is a bending, there will be some shear coming on the beam. Your column will be under some kind of compression, direct compression, as well as it will be coming under some kind of bending. When there is some kind of bending, there will be some kind of shear also coming on the column, okay? However, you see, generally if the beam is rigid, in such case there will not be any tension getting generated inside the beam. Is it clear?
Yes, sir.
Okay.
Yes, sir.
Okay. So if you have any other question, then otherwise we will stop. Yeah, tell me.
Sir, which book we prefer for this subject, sir?
Which book? Okay.
Yes, sir.
Book you can see. Book you can take. Basically, the Bhabikatti's book you can study. Okay. R.C. Hibbeler's book is a good book. Okay. R.C. Hibbeler, Engineering Mechanics. I have given you one copy, right? I have collected one copy from one of your friends only, from section 1, R.C. Hibbeler's structural analysis. I can share that also. R.C. Hibbeler's book is a very, very good book. Means you should not worry that many things are written over there. It's a very good book. Like the engineering mechanics, you can study. Like the engineering mechanics, you can study your R.C. Hibbeler's book. Okay, R.C. Hibbeler's book I will share with you. Just wait for another 2-3 days. This week you wait. Okay, we will try to find out some good books and share the e-books with you. Okay, we have shared in the previous semester also, exactly like that we will share with you. Is it okay?
Sir?
Okay.
हाँ बोलो.
Sir, is there any term called structural dynamics?
Is there any term? Yes, there is term. There is a structural dynamics is a very important subject. It's a very interesting subject. Okay. So structural dynamics is the study of structure under the dynamic loads. And I have explained you that earthquake load, the seismic load, right? It's a dynamic load. Wind load is a dynamic load. So if you want to study the structure under dynamic load, you will have to study using structural dynamics. So it is not under the purview of this structural analysis course. Maybe I think in the 6th semester some course is there. You can go for some elective course where you can study about the structural dynamics. If you choose it, you will be able to study it. Okay.
Thank
how,
you, sir.
how do I collect these roll numbers? Do anyone know? So should I just copy and paste?
यस कॉपी पेस्ट कर सकते हैं
All of you have given attendance, right? Here.
सर यस शिफ्ट शिफ्ट से होगा सर
Shift से.
फिर डिलीट
हाँ?
हाँ शिफ्ट को लेकर कीजिए शिफ्ट और शिफ्ट यस सर शिफ्ट और एरो डाउन एरो
Shift down arrow. Just a minute. Huh? Okay. Control C, na? Control C. Then just a minute. Huh?
यस सर
I'll just paste it. Anyway, you are giving attendance using your this one also. So and then I'll just take a screenshot of this that everyone has come. So more people were there, I think. Someone has left, I think.
यस सर लेफ्ट
Okay, anyway. So okay, we'll stop here today. I think 28 people were there, na? 28 people were there, I think. Anyway,
यस सर
okay.
Thank
So
you, sir.
You study these things, huh? Little bit. Okay, then we will discuss more on the structural analysis. Okay. Thank you. Thank you
Thank you,
very
sir.
much. Thank you very much. Okay.
थैंक यू
Thank you, sir.